Chapter 8, Constant Capital and Variable Capital, Karl Marx, Capital, Volume 1. Why does Marx in Chapter 8 insist that your laptop, no matter how expensive, will never once do a single hour of overtime for its owner, but you will? Last chapter, we split the working day into two invisible halves, necessary labor time and surplus labor time. Today, Marx takes a step back and splits something else entirely, the money the capitalist spends in the first place, into two categories that behave in completely different ways once they enter production.
So this is less about the worker now, and more about where the money actually goes before it even reaches them.
Exactly right. And the distinction sounds almost accountant-like at first, dry, technical, the kind of thing you would expect in a ledger, not a revolutionary work of economics. It is anything but. This is the chapter where Marx quietly plants the seed for one of his most argued over ideas in the whole book, though we will not harvest that fully until Part 5. And it is worth saying plainly, this chapter has almost no drama in it on the surface. Nobody gets exploited more visibly here. Nobody works a longer shift. It is closer to Marx pulling apart a clock, piece by piece, on the table in front of you, showing you which gears simply pass motion along, and which one, quietly, is the spring.
Why does a distinction, this dry, end up mattering so much for everything that follows in the book?
Because almost every argument Marx makes in later chapters about machinery, about the length of the working day, about crisis and competition between capitalists, all of it quietly depends on being able to say, with confidence, which part of an investment can grow and which part simply cannot. Without today's chapter, Chapter 7's arithmetic is just an interesting story about one spinner and one spindle. With today's chapter, it becomes a general law, applicable to every workshop, every factory, every office, in every country, for as long as this basic wage relationship exists. So although it reads like bookkeeping, we are really watching Marx build the ruler he is going to use to measure everything else in this book. Part 1. Two kinds of money behaving differently. Not all spending is equal. Some money multiplies. Some money just disappears into what it bought. Why does buying a machine never make you richer, but hiring a person sometimes does? Think about a paintbrush and the painter holding it. The brush costs something, and over months of use it wears down, loses bristles, eventually needs replacing. Its entire economic story is that it slowly transfers its own worth into the paintings made with it, a little at a time, and never a penny more. The painter is a different story entirely. The painter's skill, time, and effort can turn a blank canvas and some pigment into something worth vastly more than the cost of the brush, the paint, and the painter's own lunch combined.
Can you put that into something even more everyday, before we go back to Marx's own words?
A bakery. Flour goes in one door, bread comes out the other. The flour becomes bread at exactly its own value, plus whatever the baker's own labor adds. The flour itself does not create anything, it simply gets transformed and passed along, cost for cost. The baker, on the other hand, through actual hours worked, kneading, shaping, timing the oven, adds value to that flour beyond what the flour itself was ever worth. Every single ingredient in that kitchen sorts itself into one of exactly two piles, once you know to look. Flour, yeast, salt, the oven itself, the mixing bowl, all of it in one pile, quietly transferring, never growing. The baker alone, standing in the other pile by herself.
Is there an older example of this, something further back than factories, that shows this split was not invented by industrial capitalism?
There is, and it is a good one, because it takes us 3 centuries earlier than Marx's own cotton mills. In the 1500s, the Fugger banking family of Augsburg, one of the wealthiest merchant houses in Europe, financed silver and copper mining across the Tyrol, in what is now Western Austria. The Fuggers paid for two very different things at once. They paid for timber to shore up the mine shafts, for iron tools, for the ore itself once extracted. and separately, they paid wages to the miners who actually dug, hauled, and smelted. Even in the 1500s, long before anyone used Marx's language, these two kinds of spending behaved completely differently. The timber and tools simply wore down and got replaced, transferring their cost into the finished silver, ounce by ounce. The miner's labor was the only part of that entire operation capable of turning a mountain of raw rock into something worth dramatically more than the rock itself. The Fuggers, remarkably, kept detailed account books tracking exactly this, centuries before anyone called it constant and variable capital.
Did anyone else in that era organize production in a way that shows this even more clearly?
One extraordinary example, rarely discussed outside economic history circles, the Venetian arsenal, the state shipyard of the Republic of Venice, operating from the 12th century right through to the collapse of the Republic in 1797. At its peak in the 1500s, the arsenal could assemble a fully equipped war galley in under a single day, using something startlingly close to an assembly line, 3.5 centuries before Henry Ford. Hulls moved along a canal, past standing stations where workers added ropes, sails, weapons, and rigging in sequence, each station stocked in advance with pre-made components, timber, pitch, canvas, iron fittings, all constant capital, all simply waiting to be assembled. The arsenalati, the skilled workers themselves, numbering in the thousands, were the one element in that entire canal capable of turning a floating hull into a functioning warship worth many times the value of its parts. Venetian administrators tracked, obsessively, in state records that survive today, the cost of rope and timber separately from the wages paid to workers, for reasons of naval budgeting, 400 years before Marx gave that same split a name. Now recall Chapter 7's cotton spinning example, because Marx is about to split it apart properly, using this exact same logic. Remember 10 pounds of raw cotton, worth 10 shillings, the spindle wearing down by 2 shillings worth during the process, and a spinner paid 3 shillings a day. Marx now gives these pieces of the puzzle formal names. The 10 shillings spent on cotton and the 2 shillings worth of spindle wear he calls constant capital, the part of capital turned into means of production, raw material, instruments, auxiliary material, and critically, he says this part does not change its value in the process of production. The 3 shillings spent on the spinner's wage, however, he calls variable capital, the part of capital turned into labor power, and this part does change its value, reproducing its own equivalent, the 3 shillings the worker needs to live, and then adding an excess on top, a surplus, over and above that.
So constant capital just passes its value along unchanged, and variable capital is the only part that can actually grow.
Precisely, and that word, variable, is doing a lot of work. It varies, because the amount of new value it creates is not fixed by what was paid for it, unlike everything else in the production process.
Was anyone actually formalizing this kind of accounting closer to Marx's own era? Someone building the ledgers themselves, rather than just financing mines or shipyards?
Yes, and it is a name most people know only as a brand of fine china, not as an accounting pioneer. Josiah Wedgwood, founder of the Wedgwood Pottery Works in Staffordshire, England, in the 1770s and 80s, faced a genuine business crisis when a downturn hit his sales. To understand what was going wrong, he began, for what may be the first time in English manufacturing, systematically separating his costs into distinct categories in his private notebooks, the price of clay and glaze on one line, the wages of his potters and painters on another, the wear on his kilns and molds on a third. What Wedgwood discovered, working this out largely on his own, with no economic theory to guide him, was that he had been pricing some of his pottery below what it actually cost to make, because he had never properly separated what his materials cost from what his workers' skill actually added. Once he could see the two piles clearly, exactly Marx's two piles, he could finally price his ornamental vases and tableware accurately, and Wedgwood pottery went on to become one of the most successful manufacturing businesses of the entire 18th century. He never called it constant and variable capital. He built the distinction anyway, out of pure commercial necessity, decades before Marx put a name to it.
Was there a moment when merchants first got the tools to even see this split clearly on paper? Before Wedgwood, before the Fuggers even.
1494, Venice again remarkably. A Franciscan friar and mathematician named Luca Pacioli published a book called the Summa de Arithmetica, which included the first widely printed description of double-entry bookkeeping, the system of recording every transaction twice, once as a debit, once as a credit, that underpins essentially all business accounting used anywhere in the world today. Pacioli did not invent the practice himself. Venetian merchants had been quietly refining it for over a century, but his book spread it across Europe for the first time. What double-entry bookkeeping made possible, for the first time in a systematic, teachable way, was exactly the separation Marx relies on 3.5 centuries later, tracking what was spent on materials and tools in one column, and what was spent on labor in another, and watching, transaction by transaction, which column's value simply moved through the business, and which column's value came back larger than it went in. Pacioli was not writing economic theory. He was writing an arithmetic textbook. And yet without his ledger columns, it is hard to imagine Marx, or the Fuggers, or Wedgwood, ever being able to see the distinction this chapter draws quite so clearly in the first place. From Pacioli's ledger columns in Venice, to the Fuggers' silver, to the Arsenal's galleys, to Wedgwood's kilns, to a Manchester spinning mill, the same two piles keep sorting themselves out, across 5 centuries, in 5 completely different industries. Hold that distinction carefully, because Part 2 is going to test it against every clever machine, and every clever accountant you can think of. Part 2, Why Machines Cannot Cheat. A spindle has never once asked for a raise, and never will. The most loyal, hardest working object in the factory still cannot create a single extra penny. Marx is careful here, almost stubbornly careful, because this is exactly where his contemporaries and plenty of people today get confused. A machine can be extraordinarily productive, can replace dozens of workers, can run for 18 hours a day without complaint. None of that changes the basic economic role it plays.
Why not, though? Surely a more efficient machine adds more value than a worse one.
A more efficient machine lets more products get made in the same time, true. But look closely at where the machine's own value goes. Marx's rule stated plainly, instruments of labor transfer value to the product only in proportion to their own wear, never more than they themselves are worth, no matter how skillfully or how quickly they are used. There is a wonderfully specific historical illustration of this, from the Cornish tin and copper mines of the 1700s and 1800s in the far southwest of England. Cornish mining companies use something called the cost book system, a form of shared ownership and accounting where investors, called adventurers, held shares in a mine, and a mine captain kept a running ledger, updated monthly, splitting every expense into strict categories. Timber, candles, gunpowder, and crucially, the enormous coal bills for the Bolton and Watt steam engines used to pump water out of the deep shafts, all recorded separately from the wages paid to the bow maidens who sorted ore on the surface, and the tinners who worked underground. The cost books show, in black and white, 2 centuries before Marx, exactly his distinction in practice. The engines, however powerful, however much water they pumped, however many tin miners they kept from drowning, only ever appeared in the ledger as a cost to be recovered, ounce of tin by ounce of tin. They never once appeared as a source of new value in their own right.
James Watt himself is an interesting figure to bring in here, isn't he? Since his own engine is the machine everyone actually remembers from this period.
He is, and there is a nice irony buried in his own business arrangement. Watt and his business partner Matthew Bolton did not simply sell their steam engines outright. For years, They charged mine owners a royalty based on the coal the new engine saved compared to the older, less efficient Newcomen engines it replaced, a portion of the savings, paid annually, sometimes for decades. Even Watt, inventing arguably the most consequential machine of the entire Industrial Revolution, could only ever capture value as a share of costs the engine transferred and saved, never as some independent value the iron and brass conjured up on their own. The engine, brilliant as it was, remained, in Marx's terms, constant capital through and through.
What about something less physical today, something like software?
Even more precisely constant capital in Marx's exact sense. A tech company's cloud computing bill, its software licenses, these are essential, often enormous costs, and they behave exactly like the Cornish steam engine or the spindle in Chapter 7. They transfer their cost into whatever gets built using them. They never multiply on their own. A server does not work harder because it wants a promotion. It processes exactly what it is asked to process, and its cost gets divided across that output, cleanly, predictably, forever.
Does it matter whether something gets used up in one go, like the cotton, or worn down slowly, like the spindle or the steam engine? Are those really the same category?
Good catch, and Marx addresses this directly. Raw cotton is consumed entirely in a single pass through production, all 10 shillings worth transferred into the yarn immediately. The spindle, or the Cornish engine, wears down slowly, transferring only a small fraction of its value with each use, taking years to fully transfer. Different speeds, completely different physical objects, and yet economically, Marx places them in exactly the same category, constant capital. Because both simply pass along value they already had, neither one creates anything new.
Is there an example of this even further back than the Cornish mines, something from the very dawn of mechanized production?
Go all the way back to Johannes Gutenberg, in Mainz, in the 1450s, and his movable type printing press, often credited as the single most consequential machine before the Industrial Revolution itself. Gutenberg's metal type, cast in mold after mold, his press frame, his ink formula, all of it constant capital in the purest sense, transferring a fraction of its cost into every page printed, the same letter used thousands of times before it wore down enough to need recasting. And yet Gutenberg's own business, financed heavily by the moneylender Johann Fust, ultimately collapsed into a lawsuit, with Fust seizing Gutenberg's presses and type when a loan could not be repaid on time. The compositors, the skilled workers who actually arranged the type, letter by letter, page by page, using judgment no mold or press possessed, were the one part of that entire operation capable of turning blank paper and cast metal into something worth vastly more than its ink and lead. The press revolutionized the spread of human knowledge itself, and it still, in Marx's exact economic sense, never created a single new unit of value on its own.
Is there a lesson in the lawsuit itself, in Fust actually taking the presses away from Gutenberg?
There is, and it is a quietly sharp one. Fust, the moneylender, ended up owning the machinery, the constant capital, and went on to run a highly profitable printing business with Gutenberg's former assistant, Peter Schoffer, while Gutenberg himself, the actual inventor, died in relative poverty. Ownership of the constant capital, it turns out, mattered enormously to who captured the resulting value, entirely separate from who had actually invented the process or done the skilled work of setting the type. A pattern, again, that repeats itself in one form or another across every single example this chapter is built from.
Did that same tension between typesetters and machines ever come back around, much closer to our own time?
It did dramatically in London in 1986. For over a century, newspapers had been set using hot metal typesetting, skilled compositors casting individual lines of lead type by hand, a direct descendant of Gutenberg's own process, still requiring exactly the kind of trained human judgment no machine yet replaced. Rupert Murdoch's News International decided to move all of its British newspapers, including the Times and the Sun, to a new plant in Wapping, East London, switching to electronic, computerized typesetting that could be operated by journalists directly, bypassing the printers' unions almost entirely overnight. Around 6,000 print workers went on strike rather than accept the change, and the dispute turned genuinely bitter. Mass picketing outside the Wapping plant, violent clashes with police, lasting more than a year. News International won, the print unions were broken, and hot metal typesetting across the entire British newspaper industry effectively ended within a few years. Seen through this chapter's categories, Wapping was a battle, fought with real economic and physical force, over exactly the conversion this chapter describes. Compositors' variable capital, their trained hands and judgment replaced almost entirely by constant capital. Computer terminals that, however fast, however cheap to run, could still only ever transfer their own cost into each finished page. So we have now confirmed the boring half of the story, if you want to call it that. Cotton, spindles, steam engines, servers, licenses, all of it constant, all of it transferring, none of it multiplying, no matter how well it performs its job. Which means there is exactly one place left in the entire production process where new value could possibly come from. Part 3. The one ingredient that multiplies. There is exactly one thing you can buy that sometimes gives you back more than you paid for it, and it is not a thing at all. Hire 10 machines and you have 10 machines. Hire 10 workers and something else can happen. Picture a vending machine. You put an exact change, and it gives you back exactly what that change is worth, a drink, a snack, nothing more, nothing less. Now picture a garden. You plant a handful of seeds, and if conditions go well, you harvest far more seeds than you planted. A vending machine can never become a garden, no matter how well built it is. But labor power, Marx argues, is closer to the garden than to the vending machine, because of what happens when it actually gets put to work across a full day.
Let's finish the spinning example properly now, with both halves of the split laid out together.
Let's do exactly that. Across the working day, the 10 shillings of raw cotton reappears, untouched in value, inside the finished yarn. The 2 shillings of spindle ware reappears too, also untouched, simply transferred. 12 shillings of constant capital in, 12 shillings of constant capital out, not a penny more. But the spinner's 3 shillings of wage behaves completely differently. Across a 12-hour working day, remember from Chapter 7, the spinner's labor adds new value at a steady rate, roughly 3 shillings worth every 6 hours. Over the full 12 hours, that adds up to 6 shillings worth of brand new value created, from a wage that only cost the capitalist 3 shillings to begin with.
So the constant capital, the 12 shillings, comes out of the process exactly as it went in, but the variable capital, the 3 shillings, comes out doubled.
Precisely that. Marx states the general principle behind this cleanly labor power in the very act of being used adds a value greater than its own value, and he calls this excess, quite plainly surplus value. Not profit yet not quite, that word comes later in the book, once other costs enter the picture. But this is its birthplace right here in the gap between 3 shillings paid and 6 shillings created.
Is there a moment in history where you could actually watch this gap disappear, where the constant capital side of the equation broke down, and you could see exactly what happened when it did?
There is, and it happened in Marx's own lifetime, in the very industry he uses for his example. Between 1861 and 1865, the American Civil War triggered what historians call the Lancashire Cotton Famine. The Union naval blockade of Confederate ports cut off the supply of raw American cotton to the textile mills of Lancashire in northern England, the same mills Marx had in mind writing this very chapter. Suddenly, the constant capital side of the equation, the raw cotton itself, simply vanished. And here is the striking part. The spindles were all still there, gleaming, well-maintained, fully capable of spinning. The mill building still stood. The workers were still willing and able to work. But without cotton to feed into those machines, none of it mattered. Hundreds of thousands of textile workers across Lancashire were thrown out of work, not because their labor had become less valuable, and not because the machines had broken, but because one specific piece of constant capital had disappeared from the supply chain entirely. Local relief committees were formed, funded partly through public subscription, and some unemployed millworkers were put to work building parks and reservoirs, projects still standing in Lancashire towns today, paid a relief wage to survive a crisis created entirely on the constant capital side of the ledger. Marx himself followed this crisis closely in his journalism at the time, watching, almost in real time, the categories he was formally defining in this chapter play out on the streets of Manchester and Blackburn.
Has anything similar happened more recently? Something people might actually remember living through?
Yes, and it is a remarkably close parallel. Between 2020 and 2022, a global semiconductor shortage, triggered by pandemic disruptions and surging demand for electronics, left car manufacturers around the world without enough microchips to finish building vehicles. Factories with fully staffed assembly lines, workers present, ready, paid, and highly skilled, sat partially idle, or produced half-finished cars parked in vast lots awaiting a chip that might arrive months later. Major manufacturers lost millions of units of production, not because of a strike, not because workers refused to work, but because one narrow category of constant capital, a component costing only a few dollars each, had become suddenly, catastrophically scarce. Cotton in the 1860s, silicon in the 2020s, the exact same structural vulnerability, a century and a half apart.
Was there a version of this crisis that hit far more industries at once, not just one textile region?
There was roughly a century after the cotton famine. The 1973 oil crisis, triggered when major oil-producing nations imposed an embargo during the Arab-Israeli War of that year, sent energy prices spiking across the entire industrialized world almost overnight. Energy itself, coal, oil, electricity, is about as pure a form of constant capital as exists, an input that transfers its cost into whatever gets produced with it and creates nothing new on its own. When that input suddenly quadrupled in price, factories across Europe, North America, and Japan found their constant capital costs exploding, while their workers, their variable capital, remained exactly as skilled and as present as the week before. The result was a strange, uncomfortable economic condition economists at the time struggled to even name properly: stagflation, rising prices alongside rising unemployment, a combination that classical economic models of the previous decades had assumed could not really happen together. Seen through this chapter's categories, it makes a certain grim sense: a sudden constant capital shock, energy, rippling through every single industry that depended on it, echoing the same basic vulnerability Lancashire discovered with cotton in the 1860s, only now on a genuinely global scale.
Is there an even narrower example, something disrupted by a single natural event, rather than a war or a global pandemic?
2011, Thailand. Severe monsoon flooding submerged industrial parks outside Bangkok that happened to house a huge share of the entire world's manufacturing capacity for computer hard disk drive components, ball bearings, magnetic platters, precision motors. Factories worldwide making finished hard drives, in countries with no flooding at all, workers fully present and fully able to work, suddenly found themselves without the specific constant capital components those Thai factories supplied, and global hard drive prices roughly doubled within months. It is almost a miniature, contained repeat of the Lancashire cotton famine, one narrow link in a supply chain breaking, and an entire downstream industry discovering, all at once, just how completely its variable capital depended on constant capital it had never thought twice about. And once you can see this gap clearly, once you understand both how surplus value gets born and how fragile the constant capital side of it can actually be, a genuinely practical question follows immediately, one that every business, every investor has been calculating in some form ever since. whether they use Marx's language for it or not. Part 4. Why this distinction actually matters. Two companies can spend the exact same amount of money and still have completely different profit potential. This is the difference every investor since Marx has quietly been calculating, whether they call it that or not. Imagine two factories, each investing exactly 1 million units of currency. Factory 1 is highly automated. Most of that million goes into machines, constant capital, with only a small slice going to the wages of a handful of technicians overseeing the equipment. Factory 2 is labor-intensive. Most of the million goes into wages for a large workforce, variable capital, with only a small slice spent on basic tools.
So even though they spent the identical amount, Marx's framework says these two factories are structured completely differently underneath.
Completely differently, because only the variable portion in Marx's account is capable of producing new value beyond its own cost. Factory 2, spending more on wages, has in this framework a larger base from which surplus value can be generated. Factory 1, leaning heavily on machinery, has converted much of its investment into something that can only transfer value, never create it.
Is there a specific historical business that actually made this exact bet, one way or the other, and it is worth knowing about?
There is a fascinating one from Lyon in France in the 1830s, a case most people outside French labor history have never heard of. Lyon was the center of European silk weaving, and its skilled weavers, known as khanates, worked on handlooms, often in their own homes, paid piece rates by silk merchants who owned the raw silk and controlled the finished cloth. This was itself a version of the putting out system we discussed with Chapter 7. Into this world came the Jacquard loom, a mechanical loom using punched cards to automate complex woven patterns, patterns that previously required a highly skilled weaver's constant attention. The Jacquard mechanism let merchants shift investment sharply toward constant capital, machinery, and away from paying skilled weavers for their judgment pattern by pattern. In 1831, and again in 1834, the khanates of Lyon rose up in open revolt, seizing parts of the city, under a banner that read, "Live working or die fighting." Both revolts were put down by the French army, at real cost of life. The Khanate revolts are rarely taught outside specialist French history courses, yet they are one of the very first organized worker uprisings explicitly against the shift from variable capital toward constant capital, decades before Marx wrote a word of capital, and grounded in exactly the anxiety this chapter is describing, that machinery was displacing the one input capable of creating new value, in favor of the one input that could only ever transfer it.
Is there an industrial example of a company deliberately weighing these two kinds of spending against each other, rather than just automating by default?
Alfred Krupp's steelworks in Essen, Germany, through the middle decades of the 1800s, offers a genuinely unusual case. Krupp invested enormously in constant capital, cutting-edge Bessemer steel furnaces, precision machinery for casting cannon and railway wheels, among the most advanced industrial equipment in Europe at the time. But Krupp also poured a striking amount of money into what he considered his workforce's own reproduction, building an entire company town, worker housing, a hospital, a pension fund, a consumer cooperative selling goods to employees at reduced prices, decades before German state social insurance existed. Krupp's own private writings show he believed, quite explicitly, that a stable, loyal, well-provisioned workforce produced better steel than a machine alone ever could, an intuition that lines up closely with this chapter's argument, that only living labor, properly maintained and motivated, is capable of creating value beyond what was spent on it. Whether Krupp's paternalism was genuine care or simply a shrewd variable capital investment, historians still debate. Either way, his ledgers show an industrialist consciously, deliberately, balancing spending on machines against spending on the one input he seemed to sense. Correctly, machines alone could never replace.
Is there a company today that consciously wrestled with this same trade-off, rather than simply automating as fast as possible?
There is, and it comes from an unexpected place, the Toyota production system, developed in Japan across the 1950s through the 1970s. Toyota's engineers coined a principle called jidoka, sometimes translated as automation with a human touch. Machines were deliberately designed to stop themselves the instant a defect appeared, rather than running unattended and producing flawed parts at speed, which meant a human worker still had to be present, still had to exercise judgment, at exactly the point where value was actually being added or lost. Toyota's own internal reasoning, documented extensively by production researchers, was explicitly practical rather than philosophical, fully unattended automation, in their experience, often produced large volumes of defective, worthless output before anyone noticed, whereas keeping a thinking, judging worker in the loop protected quality precisely at the moment machinery could not. Whether or not Toyota's engineers had ever read a word of Marx, they arrived, independently, at a working respect for exactly the distinction this chapter draws, that judgment, adaptability, and the capacity to catch a problem in real time belongs to variable capital alone, and no amount of constant capital, however sophisticated, fully replaces it.
Did anyone ever take the opposite strategy, trying to own every piece of their own constant capital supply chain outright, rather than balancing spending against workers?
Henry Ford in the 1920s attempted exactly this, and it produced one of the strangest, least remembered failures in American industrial history. Worried about his dependence on British-controlled rubber plantations in Asia for the tires his cars needed, Ford purchased an enormous tract of land in the Brazilian Amazon, roughly the size of a small American state, intending to grow his own rubber trees and control that entire piece of constant capital himself, from raw sap to finished tire. He named the settlement Fordlandia and built an entire American-style town there, complete with a hospital, a golf course, and suburban-style housing for workers recruited from across Brazil. The project collapsed within a decade. Ford's engineers, expert in assembly lines, understood almost nothing about tropical agriculture, planting rubber trees too closely together, which let a leaf blight spread rapidly between them, something that never happens in the rubber tree's native, naturally scattered habitat. Workers, unhappy with imposed American food, working hours, and a ban on alcohol, rioted more than once. Fordlandia never produced a meaningful amount of usable rubber, and Ford eventually sold the land back to the Brazilian government at a steep loss. It stands as a genuinely instructive failure, an industrialist attempting to fully absorb his constant capital supply chain, while badly misjudging the variable capital, the actual human labor and expertise, needed to make that supply chain function at all.
And the rise of AI and automation today reads as a very direct echo of that whole two-century argument, doesn't it?
A very direct echo. When a company replaces workers with software or robotics, in Marx's precise terms, it is converting variable capital into constant capital. Fewer wages paid, more spent on machines and licenses instead. The efficiency gain can be real and significant. But through this exact lens, that same company is also shrinking the one part of its spending that Marx argues is actually capable of producing new value in the first place. The same underlying tension the Lyon silk merchants and their weavers fought over in the streets, and the same tension Toyota's engineers tried to design their way around a century later.
Is that reflected in ordinary corporate arguments too, not just historical revolts or big automation headlines?
Constantly. Watch any corporate budget meeting argue over headcount versus tooling spend, whether to hire another person or buy another piece of software or another AI subscription instead. That argument, dressed up in modern language, spreadsheets, quarterly targets, is a direct modern echo of exactly the split Marx draws in this chapter: constant capital against variable capital, argued out line item by line item, the same way a Lyon silk merchant once weighed a loom against a weaver, and a Toyota engineer once weighed a fully automated line against one with a human still watching for defects. Marx does add one specific warning here, aimed squarely at economists of his own time, and it applies just as well today. He cautions against confusing the physical role a thing plays, a machine doing an enormous amount of visible, impressive work, with its economic role in producing new value. However much work a machine physically performs, only living labor power in his account actually creates value beyond its own cost. The machine can be indispensable, remarkable, transformative, and still, economically, only ever a very sophisticated form of the spindle, or the Jacquard card, or the Cornish steam engine.
That raises an obvious, slightly unsettling question about the long run. Then,
It does, and that question is exactly where Chapter 8 has been leading us the entire time. Part 5. What Chapter 8 quietly sets up. This chapter looks like bookkeeping, and it is actually the foundation for one of Marx's most controversial predictions. Once you can separate these two kinds of capital, you can start asking an uncomfortable question about the future of profit itself. Before Marx, most classical economists tended to lump all capital together into one undifferentiated pool, money invested, money returned, without asking whether the money spent on machines and the money spent on wages played fundamentally different roles inside production. Marx thought this blending hid something important, and Chapter 8 is him carefully, patiently prying the two apart, using the Fugger's silver mines, the Venetian arsenal's canal, the Cornish cost books, and Lancashire's idled spindles as his evidence trail, whether he named them directly or not.
before we get to Marx's own century, was there an even more direct, physical confrontation over exactly this shift, workers actually fighting the machines themselves?
Yorkshire, England, between 1811 and 1816. Skilled wool finishers known as croppers, who used heavy hand shears to raise and trim the nap of woven cloth, a task demanding years of trained judgment, found themselves facing a new machine called the gig mill, and the shearing frame, mechanical devices that could do a rough version of their work far faster, requiring only unskilled operators. Groups of croppers, organizing under the name of a possibly mythical figure called Ned Ludd, broke into workshops at night and smashed the new machines, in actions that were, in a very literal sense, an attempt to physically destroy constant capital before it could permanently replace variable capital. The British government responded by making machine breaking a capital offense, punishable by death, and deployed more soldiers to suppress the Luddites than Wellington had, at that same moment, fighting Napoleon's forces in Spain. Several Luddites were executed, others transported to Australia. It is one of the most dramatic, and most frequently misunderstood, episodes in this entire history. Popular usage today treats a Luddite as simply someone who fears technology in general, when the actual croppers of Yorkshire were skilled workers making a very specific, very Marxian argument with their hammers, that the machine could only ever transfer value, while their own trained hands had been creating it.
Did anyone in Marx's own century notice this same worry about the future before Marx himself formalized it?
One figure worth naming here, and rarely brought into these conversations, is the economist John Stuart Mill, a contemporary of Marx working from a very different political tradition. In his Principles of Political Economy, published in 1848, the same year as the Communist Manifesto, Mill devoted real attention to what he called the tendency of profits to a minimum, worrying, from an entirely liberal, non-revolutionary standpoint, that competition and mechanization might squeeze returns on capital over the long run. Marx read Mill closely and disagreed with him on almost everything else, yet this one worry, that something about accumulating machinery might not simply keep delivering ever-rising returns forever, was very much in the intellectual water of the 1840s and 50s, not something Marx invented from nothing.
And today's automation anxiety fits directly into that same lineage, doesn't it?
It fits almost too neatly, And there is a very current, very specific example worth knowing, beyond the usual warehouse robot headlines. In the 2010s, the electronics manufacturer Foxconn, which assembles products for major technology brands across enormous factory campuses in China, announced a program to install what it called Foxbots, robotic arms designed specifically to replace assembly line workers doing repetitive tasks like polishing and simple assembly. Foxconn's own leadership stated a goal of reducing its workforce by hundreds of thousands of positions over a period of years, converting an enormous amount of what Marx would call variable capital directly into constant capital, robotic arms that, however precise, however tireless, only ever transfer their own cost into the phones and laptops they help assemble. There is an older, less remembered echo of exactly this same worry too. In 1930, in the depths of the Great Depression, the economist John Maynard Keynes published a short essay called Economic Possibilities for Our Grandchildren, predicting that within a century, technology would have advanced so far that his own grandchildren's generation would face what he called technological unemployment, work disappearing faster than new work could be invented to replace it. Keynes, no follower of Marx, arrived from an entirely different theoretical direction at a strikingly similar worry. That machinery displacing labor was not simply a temporary, self-correcting adjustment, but potentially a structural feature of an economy that kept converting more and more of its investment into machines.
Was there anyone even closer to our own technological moment who raised this same alarm early? Someone from mathematics or engineering rather than economics.
Norbert Wiener, the American mathematician who founded the field of cybernetics, the study of feedback and control in machines and living systems, published a book in 1948 called Cybernetics, and followed it in 1950 with a more public-facing work called The Human Use of Human Beings. In it, writing at the very dawn of the digital computer, decades before anyone said the words artificial intelligence, Wiener warned, quite explicitly, that automatic machines capable of adjusting their own behavior, what he called the new industrial revolution, would devalue the ordinary human factory worker to the point of being not worth hiring at any price. His own phrase, unless society made deliberate choices about how the resulting gains got distributed. Wiener was not a Marxist and was in some ways deeply hostile to centralized economic planning. Yet a mathematician, working from pure engineering logic about feedback and control systems, arrived independently at almost the identical structural worry this chapter sets up, that a machine capable of replacing a worker's judgment does not simply do that worker's job better. It potentially removes, permanently, the one input in the whole production process capable of creating new value in the first place. Now, this is exactly where I need to be careful and fair, rather than dramatic. What follows from this chapter's logic is a genuinely contested implication, not a settled, proven fact, and economists, including plenty who take Marx seriously, disagree sharply about it. The implication some draw from this framework is this. If only variable capital, only living labor can create new value, then a firm, or even an entire economy, replacing more and more workers with machines, is trading away its own primary source of surplus value even while chasing efficiency, a paradox that sits uncomfortably against the common, almost automatic assumption that automation is simply, straightforwardly, good for profit, without limit.
Is that a settled prediction then, that automation eventually undermines profit itself?
Not settled at all, and it would be dishonest to present it that way. Marx himself develops this idea much further and much more carefully later in the book, and even there it remains one of the most debated parts of his entire theory. Critics point out that automation also lowers costs, opens new markets, and that profit rates depend on many moving parts beyond this one ratio. And note that Keynes's own 1930 prediction of mass leisure has, so far, not fully arrived either, 100 years on, which should make anyone cautious about betting too heavily on any single long-range forecast from any economist in any tradition. Others, sympathetic to Marx, argue the long historical record of profit rates does show exactly the kind of pressure this chapter predicts. Both serious positions exist, and reasonable economists, then and now, land on different sides of it, much as the Lyon silk merchants and the Connaughts themselves once did, from opposite ends of the same loom. What Chapter 8 itself actually proves, carefully and modestly, is smaller than that larger prediction, but still genuinely important. That not all capital behaves the same way inside production. That machines, however impressive, only ever transfer value. And that living labor power remains, in Marx's account, the one and only source of anything new. Everything else, the automation debate, the long-run future of profit, gets built on top of this foundation in later chapters, not settled here.
Has anyone recently tried to actually measure this split, the way Wedgwood or the Cornish mine captains once did, but across an entire modern economy?
The French economist Thomas Piketty, in his widely discussed book Capital in the 21st Century, published in 2013, spent hundreds of pages doing something that rhymes closely with this chapter: tracking, across 2 centuries of tax and inheritance records from multiple countries, the share of total national income flowing to capital, essentially Marx's constant capital returns, versus the share flowing to labor, essentially variable capital's own wage. Piketty is not a Marxist, and reaches different conclusions and proposes different remedies, taxation rather than revolution chief among them. But the underlying question, whether the return on simply owning capital tends, over the long run, to outpace the return on working, is recognizably a descendant of exactly the split Chapter 8 draws, argued out now with modern datasets instead of shilling by shilling cotton ledgers. From the Fugger's silver mines in the Tyrol, through a Venetian shipbuilding canal, past Cornish cost books and idle Lancashire spindles, through the Connaughts of Lyon rising against the Jacquard loom, a Toyota engineer refusing to fully trust an unwatched machine, and a Keynes essay written in the shadow of the Great Depression, into a modern corporate argument over headcount versus tooling budgets, and a Foxconn assembly line quietly filling with robotic arms. That is Chapter 8 of Capital, Volume 1. Constant capital and variable capital, the quiet accounting distinction underneath everything else this book has to say.